Today on Flipping Science, looking at conjugate acids and bases. So we're going to look at conjugate acid-base pairs. Acids lose protons by definition, and when they do that, they form a conjugate base. So they form something that's lost a proton, that can gain a proton, and therefore if it can gain a proton, it can be a base. Conjugate bases gain protons to form conjugate acids. So because they have an extra proton, they can lose that, and by loss, that makes them an acid. Acids lose protons. So let's look at this example down here. If we look at water reacting with ammonia, forming hydroxide ions and ammonium ions, if we look at the water here, this has lost a proton. It's got two protons here and only one proton in the hydroxide ion. So that makes this one, this is the acid, it's lost a proton, that's why it's an acid, and that means the hydroxide ion here could gain a proton. So if it can gain a proton, that makes it the conjugate base. If we look at ammonia here, the ammonia is gaining a proton. Bases gain protons by definition. So that makes this our base. And our ammonium ion over here, that's got an extra proton. So it can lose that proton, and if it loses a proton, that makes it an acid. So this one here is our conjugate acid. An easy way to help you out is to look at what's happening with the protons. If you look at the conjugate bases, they have one fewer protons compared to the acids from which they were generated. So the acid has an extra proton, it's losing that proton, and by losing a proton, it's producing its conjugate base. If we look at conjugate acids, they have one more proton than the base from which they come from. Bases gain protons, so the conjugate acid has an extra proton compared to the base. So let's look at the example here where we've got hydrofluoric acid reacting with water, producing fluoride ions and hydronium ions. We're going to start by identifying what our acid is. We need to find something that's lost a proton. So if we look at hydrofluoric acid over here, we can see that it's lost a proton. We've got one hydrogen atom here, no hydrogen atom there. So this is our acid. If we follow our simple rule, we can see that the conjugate base has one less proton than the acid. So if we look at our fluoride ion over here, we can see that's going to be our conjugate base. If we look at water, we can see that water has gained a proton to produce the hydronium ion. So if it's gaining a proton, that makes it a base. And if we follow our simple rule, to figure out which one is a conjugate acid, it has an extra proton. So it has one more proton, so that makes this our conjugate acid. Okay, so let's do this example. So to figure out which one's which, let's have a look at what we've got going on in our reaction. NH3, NH4. So NH3 is gaining a proton. Things that gain protons are bases. So this is our base. Our conjugate acid has one more proton than the base. So that means our ammonium ion here, it's got an extra proton. So this is going to be our conjugate acid. If we look at our remaining pair, we've got HSO4 and SO42 minus, HSO4 minus, sorry, and SO42 minus, so sulfate ion. So if we look at this one here, we can see it has lost a proton. So if it's lost a proton, that makes it an acid. We look at our sulfate ion here, it has one less proton than the acid that it came from, so that makes this our conjugate base. So let's do some more examples. So in this example, we have the ethanoate ion, the acetate ion, reacting with hydrochloric acid to produce ethanoic acid and chloride ions. So let's have a look at what we've got. We've got an ethanoate ion, acetate ion over here. It is gaining a proton. So if it gains a proton, that means it's a base. So this is our base. If we look over here at our ethanoic acid over here, it's got an extra proton. So if it's got an extra proton, that makes this the conjugate acid. Right? If we look at our hydrochloric acid, its name gives it away, it's losing a proton over here. So here it's got the extra hydrogen, over here it's lost it. So this is our acid. If we look over here at the chloride ion, it has one less proton than the acid from which it comes from. So that makes this our conjugate base. Alright, so today on Flipping Science we looked at the difference between conjugate acids and bases and the acids and bases which generate them.